Hi everyone, and welcome to the continuation of Vim/Neovim series. Today I'll be talking about Lua scripting and building your own modules. All the other videos will be linked in the video description, in the playlist, and you should see it also above. Go watch those first if you're interested. Alright, let's start. So why do we want to do this? If you programmed in any language, you probably created your own libraries of utilities or functions, and then you reused it across various projects, something that is just your tool belt. This is no different with Neovim and adding Lua functions. Neovim is a super extensible editor. You can add anything you want and just expand it however you need it. So we are going to focus on doing just that. That means that you should be familiar with Neovim. You're ideally someone who already created a configuration, used an editor for a while, and then you're hungry for more, and you're thinking of jumping in, developing maybe your own plugins or modules or functions. So at the end of this video, you'll hopefully be able to start writing your own modules, and I would have convinced you that having your own Neovim modules library is a really good idea. So before we start, let's situate ourselves. Where are Lua functions and in comparison to other features? The way I like to think about it, if you would like to perform a multi-step task, maybe it's a one-off, maybe you're using it for editing some complex files, that's a good candidate for a macro. You record the macro, you can save it under a key binding, and that's probably enough. However, if you find yourself needing more, code-like features, maybe you have conditionals, loops, and so on, you want to capture variables, and it's kind of more like a feature you're looking for, then Lua functions are really great. By the way, a short disclaimer, I will be focusing on Lua functions and on Neovim, but the concepts and ideas are, of course, applicable to Vim as well. After all, Neovim is, well, extended Vim. So that's where functions come in. You want to have this kind of a tool belt of your own functions and your own modules. And of course, from there, if you feel that what you do maybe brings the value to community, or you want to be more thorough about how you test it and how you go about developing it, then the plugins is an obvious next step where you can create your own plugins. It's not that hard. So a little bit of introduction to Lua in Neovim. Neovim has its own quite cool Lua API, where you can use various functions that Neovim provides and call various Lua functions. So first of all, vimcmd, it's a wrapper around external commands and Vim script. So you can, we will be doing it, but you can essentially take any command that you would type in Vim, and then you can wrap it in this vimcmd. Vim.fn, again, it's a set of APIs that helps you access Vim functions. Vim API, it's where all the Neovim stuff lives. So anything starting from nvim _, and you have plenty of functions there. And there is also others like Vim options, Vim global, all kinds of namespaces, if you will, that help you do those things. So help is really important. So let's look at it real quick. Neovim has a really cool help. So if I open Vim here and I do Lua, you can see here you have help about Lua. You can read all about it. You can also do things like maybe Lua and then list or whatever. Any kind of help is available. I highly recommend installing Telescope, and with Telescope you can go with the TS in my case, or just type Telescope and do help tags, and here you have a contextual search for help. So here I can say Lua, for example, Lua, and then I have a little bit more information here. This is also coming from plugins and other things. One neat idea that you might want to try is use something called help grep, and you can say, I want to help grep for Lua file, and help grep Lua file. And then you kind of see various help topics with the word Lua file. You can use regular expressions, and you can open quick fix lists to see where all the words are. So that's just a very brief introduction to Vim's help, and you should definitely use it. It's one of the best help systems I've ever seen in any program, which is great. All right, let's move on. So how do you use Lua in Neovim? Obviously, you can write a function, you can write a module, as we will be doing, but you can also like try out a small Lua snippets using a Lua keyboard from command line. So let's test it. So we go back to our Neovim here, and we can say, for example, let me just close this help here, and I can say maybe Lua print, and then do something like hello. And that will, of course, output hello. So I am calling Lua functions from within Neovim command line. I can do Lua, and then here with this equals stands for just Vim print, really a shortcut, and then _G is like a global namespace that holds all the Neovim global variables and commands and functions available to you throughout the session. And you can see there's quite a lot of different functions and variables. So this is your global scope. It's quite useful to explore. The rest of the commands we will look at a little bit detail when we start the demo part, but there's also a few others we can do. All right, a little bit about Lua modules. This is by no means intended to be a thorough explanation. It's just to give you enough overview so that you can start being productive with working with modules. So modules are actually an encapsulated scope. So think of a module as just a grouping or a bucket that separates the scope of variables and functions from other modules. So if you know languages like C#, you can think of them as classes or maybe modules in Go and so on. So that's a very similar concept. If you want to load another module or import it into existing module, you would use the keyword require and then in open braces the module name. If a module is located in a folder, you would use a folder name and separate it with dot and then the module name. That's just a convention. Now, you can also import modules and then assign them to variable. So then think of it as like if you have utilities module, you might want to do this, and then my mod in this case dot will provide the whole list of functions and variables that are exposed to your module. The last one is a little bit of a quirk of Neovim. If you work with modules, loading them and unloading can be a little bit of a pain. So this package loaded and then the my module array set to nil kind of clears the cache of modules, allows you to load it. It's something you'll have to get used to. All right, so what I would like to encourage you to do, and hopefully convince that this is a good idea, is to create your own user functions or your own modules. To do this, it's really easy. You first create a folder within your config nvim Lua, and then in my case, they are called user functions. You can call them however you want. And this snippet here below, it is something you put in init Lua. This is simply a piece of code that enables auto-loading all the files, all the modules. Remember, a module is just a Lua file without a .lua extension. So super easy. And this is just a convenience function that loads it instead of you having to load them manually. Nothing crazy here. So let's look how it looks in my .files. So here I have all the modules that you can see, annotate, grep project, so on and so forth. Some of them are, like a shell dedicated modules, tasks for task warrior integration and so on. Those can be anything you want them to be. It's your tool belt, it's your modules that you use within your Neovim. So let's quickly check the path. You can see here I am in config, my .files, config, Envim, Lua, and user functions right here. And I can show you again this code that I mentioned here. So here a little loop that loads those modules. Nothing really too exciting here. It's quite normal. All right, let's go back to the slides. So again, those are my modules. You can have yours however you want, and we will develop one just for fun. So how does the module look like? What makes a module a module? In simplest terms, code in Lua is organized in module. A module separates scope, and everything in a module is a table. A table in Lua is a special structure that can hold functions, variables, and other stuff. And that's it. It's a super flexible, object-like or dictionary-like structure that can express anything. So what we want to do at the beginning of our module is to declare, by convention, a capital letter M. We declare it as an empty Lua table. Then we write our functions, we create properties, variables, whatever we want, and then we return M. Notice, however, that this M dot stands before my function name, meaning that this function will be exported with the table. And then if I would import this module by using require, then I would have access to the function, my function. Conversely, if you put a variable without M, then this is its scope is only per module. Again, if you know programming, if you come from literally any programming language, this shouldn't be that difficult. That's a pretty simple isolation concept. Now, why do we want to have modules? This is really more for just maintainability point of view. You can keep your Lua code more maintainable that way. You can have modules that, you know, serve specific purpose. You can pull them and load them on demand. It's easier to work with. You could have a very, very big user functions file, which I had for quite a while, and it was okay. But once it grew, you know, I found this modular approach a bit easier. All right, so let's write a very, very basic Lua function. So we're going to swap here again, and we're going to open this greeter Lua. You can see it's just a Lua file inside my folder, nothing inside. Let me disable Copilot real quick, and we can just write a function. So let's write it. So local, this means that the function is only scoped to this file. I'm not going to export it. We're just gonna write code in this file, and then function. I am using code snippets here. Super easy, just gives me a name. Let's do greet, not green, greet. And then we just put name here. And here we do like print, similarly like the other one. You can see that I have full LSP here. Setting up LSP is outside of scope of this video, but there are plenty of great tutorials and documentation how to set up language server protocol so you can see code completion and comments and so on. So I have this print. I can say, for example, hi, and then make a little space here. Dot dot in Lua is concatenation. So hi, whatever name we want to put here, name, and then we do this, maybe consider subscribing. All right, so we have this, and then we can call. So in the same file, we are going to do greet, and then maybe put something like, hey, dear viewer. So now I have this file, it's available, and I have to somehow run it, right? So Neovim provides a very easy mechanism to run any file, to execute it. You can do this either by using source or Lua file. They behave slightly differently. I recommend using Lua file for running simple scripts. So let me save it, and then Lua file. And instead of typing the file name, I can use %, which stands for the name of the current file. And as expected, hi dear viewer, consider subscribing. So that's how Lua functions work. Again, you know, it's just language like any other. It has its own syntax, it has its own keywords, and its own way of referencing and calling functions. But I find Lua to be quite easy and nice to work with. So that's our first function. We just created it, we run it, everything is great. Now, before we start working with the demo with our plugin, I recommend installing a few plugins. First of all, plugin from Folky, who is quite well-known Neovim plugin author. He created plugins like Lazy Nvim and others. This one, neodev.nvim, helps you with completion of your Lua code and also Neovim Lua code, which is super helpful, and we will see in a moment. It's like having an IDE, then typing something, dot, and then you have a completion, all possible functions and variables. Again, Lua Guide, it's not Nvim Lua Guide, but Lua Guide help system. If you want to get like a very quick introduction to Lua in Vim, this help Lua Guide is a quite great start. It's integrated with Neovim help. And finally, if you like using REPL, which stands for Read, Evaluate, Print Loop, this is something specific for programming. I programmed earlier quite a lot in F#, which has a really powerful REPL. Neovim doesn't have it integrated, but there's a plugin that brings this REPL in. It has its own little bugs here and there, but for the most part, it's working quite well, and I will show you how to use it when we will develop our demo. But I feel those two plugins are quite nice to have, and obviously you need to set up your LSP for the language server protocol to work. Okay, so with this said, the goal for the rest of the video is to develop a module that we will call Zoomer. This will be a simple module which will hold one function, and this function will toggle a zoom state of the window. So let's imagine that we don't know much about these features, like what can we use, and we'll try to explore a little bit and see what we can do. So here we are in the Zoomer Lua file. As you can see, it's empty. So the first thing that we can do is to use help. So again, I'm using telescope and help and something like window resize. So that's a good start. So we have things like Control W and equals, balances the window sizes, and we can kind of keep on scrolling. We can have here, for example, Control W and underscore sets the current window height to whatever value we want. By default, the highest possible value. Okay, so that sounds like a good start. So we can manually do this, right? So if I open another window here, let me just open kind of one file, just init.lua maybe. So we have two windows. So if I do Control W and equals, you see that all the windows are kind of like more or less equalized. If I do Control W and underscore, you see that the current window became taller, right? So it increased the height of the window. Let me try to do Control W and pipe. Again, the pipe kind of increased completely the length of the window to take the full screen. We can see a little bit of other windows, but for all intents and purposes, that's our zoomed state. So by using, Control W and underscore and Control W and pipe symbol, we can do this. But how do we do it using Vim commands? We can also search, help. So I know for a fact that we can use Vim CMD. So win CMD, and we can actually make this window a little higher. So here, this WinCMD, it's essentially the same as we've seen with control, but this is a Vim command. So we can use this Vim CMD and issue various commands to the window. So we can, in this case, move, or we can make it taller, make it shorter, and so on. So this is how we can execute a Vim command. So how do we execute a Vim command? Again, help would be great. Vim CMD. That's probably what we want. We've seen this earlier. Neovim expositor, the Lua API. Okay, so we can use Vim CMD to execute something. So let's give it a try. So let's create help here and this guy, and we do Vim CM, and you can see I mentioned earlier about the LSP and auto-completion. So we have this Vim CMD struct, and I can do dot and then WinCMD. It's a function that I could call. And then maybe I can just do, let's do like underscore. And that's what we could do. So again, remember, this is a file. We can evaluate it by Lua file and do this. And nothing happens because we have only one window open. But let's see if we can open some other file here and see if this works now. Lua file, yeah, it worked. So it made the whole file taller, made the whole window taller. We can use a normal shortcut, Control equals to go back to our state here. So we know that it works. We know that we can actually do it. All right, so this is great. That's a good start. We already can make the window kind of vertically taller. Let's actually add this other command, and we're gonna do this. We're gonna replace this with the pipe. And in order to see this correctly, we actually can open another window here, like that, vertically maybe, and see if we can do this. If it will be correctly applied, so the window will grow taller and will grow to the right. Actually, I realized that we should put this file right here. So VSP. Let's see mappings, for example. So now when we go back to the file, our file here, and then Lua file, and do this like yes. So it pushed the other window to the right, and it pushed the other window to the bottom. So that's our zoom state. Okay, so we want to make sure that we can zoom and we can also unzoom, but you can already see probably, okay, we need some kind of variable to hold the state, whether something is zoomed or not. So let's introduce the zoomed variable. So we're gonna go to the beginning, zoomed, and you could have a naming convention, is zoomed or whatever. I'm just doing it super easy here. So zoomed false. It complains that this variable, as you can see, it's global. It treats it as a global variable, and it's in lowercase. But we don't want it to be global variable. We want it to be local. So our local zoomed is false. Okay, so we have the zoomed variable, and we have the way to manipulate our windows. But now we need some kind of function, right? So I can use fu for function, or function that's both the same snippets. I can do function and, for example, zoom toggle. Okay, and then nothing in the variable, nothing in the parameters. And in the code, we would actually take, we're gonna take this, and we will paste it here. Do this like that. So we have this. Now we need some kind of conditionals, right? So we'll say if zoom, let me switch off, disable autopilot. So if zoomed is true, so if we are already zoomed, then we want to do something like Vim CMD, WinCMD, and do equal signs. Remember, equal signs, what they do, they equalize all the windows. So they become like, essentially take position from earlier. So if the 4 windows, they will be equally separated before. Okay, so if zoomed is true, then we want to unzoom everything. Remember, this is our toggle. And I noticed that this is something wrong here. Function zoom, because we didn't finish the writing. Okay. So if this is the case, and then we do zoomed will actually be false. So we changed the status of zoomed and then we updated our variable. So the zoomed is now false. And then else, we will essentially execute those commands and then do zoomed true. And then end the if statement and the if block. So now our code is okay, and we are actually good to go. So how do we test this? We have this kind of very rudimentary structure that we're starting from the false state, which is default for Boolean variables. What we could do, we could actually call it. So we can do zoom toggle, and we could then do Lua file like we did earlier, and this would work. Oh, I misspelled zoom. So this would work, but it wouldn't revert it. You can see I'm loading the file again, and it doesn't revert the state. And the reason why it doesn't revert the state is that this variable is local, and the code is not loaded into memory as a module, but rather every single time I'm evaluating it anew. So that's not what we want. So how else can we test it? So there are various ways how you can do this. You can make a module out of it, but I want to show you how you can use the REPL environment to do this easier. So first, before we run the REPL environment, I actually want to return the function from this module rather than call it. So we do return, and then we do zoom toggle. So when this file is executed, when we load it, we are going to have a function that we can call. So it's not quite a module just yet, but we are returning our function. Remember, everything in Lua is a table. You just return it, and then we decided to return from our table just a single function. So I can do REPL environment, which is the environment I talked about earlier. And here, this little help, you can have access to various options here. But what we want to do is focus on the Lua option. And we can maybe say, we can load this to ZM for zoom. And then we can use a special construct called doFile. And doFile is a Lua construct that loads the file and enables us to evaluate it. It loads it to this global context that I showed earlier. So this is called zoomer, and then Lua, this is our file. And then if you do ZM, you see that ZM is a function. Remember, we returned a function. So when I read this file, I'm actually gonna get the function. So now I loaded it into global memory. So my state will be kind of held somewhere, and I should be able to run it. So let's give it a try. We are in this REPL. Not sure if this is a correct REPL here. Sorry for all the jumping. There you go. Here's the right REPL. So let's see, ZM, since it's a function, I'm just appending braces, and I'm doing like this. Okay, let's see if it works. There you go. So now we've been first in the false status. Now we unzoomed all the windows, and once I hit it again, it zooms my window. It again reverts to the previous state, and it works. So it's great. So everything is fine. Let's actually zoom it one more time. I can show all the buffers and then my zoomer file. So we just need one more step. So we want to make a module out of it. So you remember from the slides, the way we do modules was very simple. Local M, open the table, then return M, and that's it. So let's see if it's gonna work. So we local M, we do open and close, and instead of returning the function, we're actually gonna return M. One more thing that we have to do, we have to go to the zoom here, and we need to make an M. So remember, our module will contain this function. This is also an important point. Generally, for a programming principle, we are protecting our invariants, meaning that my zoomed variable can only be changed from inside my function. I'm not allowing any arbitrary process to modify this variable because this variable holds the state of whether a window was zoomed or not. The only thing I'm exposing here as part of my table is anything that I add to it. And the way to do this is prepend M. So now whatever I return from this module is only my zoom toggle function, which I can call from outside. Okay, so we have done it. And if we go to our REPL again, so let's open the REPL one more time. Let's make sure that we are in Lua here. And I can maybe do a zoom, and then I can do file again. And then let's say it was zoomer Lua. So now when I click zoom, you can see that it's not a function anymore that we're returning. We're actually returning a table between these curly braces. And then I can call on this object the zoom toggle function, and it will behave as you expect. All right, great. So this is good. One last thing we want to do, and this will close the loop, so to say, on creating your own modules library, is to add a key binding that you will be able to use in order to call your function. Key binding can be in different file, but can also be in the same file. I like adding my key bindings in the same file, so I have everything together. There are some circumstances that you might want to add key bindings somewhere else. The ideas are the same. So I highly recommend having a snippet for key bindings. So I have a key map snippet here. I am using vsnip, but you can also use Lua snip, or I know that recent version of Neovim comes with its own snippet set. However you do it, have a key binding snippet. When I hit enter, you can see it expands to what I can do. So let's do ZOM for zoom. Then I hit tab, and I'm going to the next part. I do M, and then let's do zoom toggle, name of the function. I want to delete this I'm sorry for that. So let's do I want to delete quotations. So it's actually a function. So now I have a key map set that will work in normal mode whenever I hit leader ZOM, and it will call our toggle function. All right. So let me restart Neovim. I'm going to close everything and then open our zoomer again. So now I have a plugin called which key. When I hit leader, which is space in my case, and I hit Z, you can see that there is an O, which follows our mapping again, and then M. Of course, we don't have any other windows. So let's open something as we did earlier. And then again, space ZOM. One more time. Space ZOM. Space. Sorry for that, space ZOM. And there you go, our window is minimized and maximized. So that's how easy it is to write it. I purposely took a little bit longer to show you how to use help and how to test it, how to use REPL, how to make sure at each step that you can do this. Your own module will not require unit tests. It will not require, extensive design. Those are meant to be quick functions, really simple, and just, scratch your own itch, help you. So I'm just gonna show you one more time some of mine's that I like. So this one, for example, is a text object, which is another topic about Neovim. But this one detects the markdown headers and allow me to operate on them, like, delete, copy, select, and so on. So all kinds of functions that you can imagine for your workflow can be done this way. All right, that's been a really long video. Thank you for staying till the end. Please do let me know in the comments below. Are you using Lua functions? Do you maybe have your favorites? Anything that you've learned that you want to apply to your own workflow and your Neovim? I will leave the link to the playlist. I will leave the link to my dot file so you can read it. And yeah, I hope you enjoyed it. Go ahead and create some Lua modules. See you in next video.